In this video, we're going to look at some examples of how to predict a product, balance the equation, and identify the type of reaction. First one here, I'm going to start with mercury 2 oxide. That is going to break down into both mercury and oxygen. First thing I need to do is check to see whether or not oxygen is going to be diatomic. If you remember, our little mnemonic is have no fear of ice cold beer. Well, oxygen is one of the ones that's diatomic, so I have to make sure to put a 2 after that. Now I have to balance it. Since I have 2 oxygens on the right, I'm going to make sure I have 2 on the left, and then of course I need to balance the mercury. Now I am balanced. This is going to be a decomposition reaction because I start with one thing and I end with multiple ones. Now I have silver nitrate plus potassium sulfate. So I need to switch those around, so I'm going to have silver joining up with the sulfate, and I'm going to have potassium joining up with the nitrate. Now what I need to do is I need to figure out the charges on it. Nitrate is a polyatomic ion with a charge of -1. Silver is going to have a charge of +1 since I only have one of those there and they have to cancel out. Sulfate is going to be a -2 charge. Potassium is always a +1 charge. So now I can go over here and I know that the silver started with a +1 charge and I'm going to have sulfate as a -2. Those don't cancel out, so I need to do the crisscross method, and then I'm going to bring that down, so it's going to be Ag2SO4. Now for the potassium nitrate, potassium's +1, nitrate's -1, so those are already good to go. Next I have to balance that. So I have 2 silver on the right, might as well get 2 silver on the left. That's going to mess up my nitrate, so I'm going to balance that by putting 2 over there. Now it's completely balanced. I have a double displacement reaction because each of them arrived and left with different partners, so to speak. Boron trifluoride plus ammonium phosphate. Well, I'm going to switch those around, so I know boron's going to join with the phosphate, and ammonium is going to join with the fluorine. So let's look at my charges on that. Fluorine is the charge of -1, which means boron has to be a charge of +3. If you go down, look at it on the periodic table, there it is right there in the +3 column. Ammonium has a charge of +1, phosphate has a charge of -3. So I know that boron is going to be +3, phosphate is -3, so they cancel, no subscripts needed there. Ammonium is going to be a charge of +1, fluorine is a charge of -1, so no bringing down of subscripts for those either. Now I need to balance it. I have 3 phosphates on the left, so I need to get 3 on the right. That is going to be a double displacement reaction because either one of them is arriving and leaving with a different partner than when they started. Iron plus water. Now in this case right here, I kind of have a mistake because they didn't really specify what the charge is on the iron. And iron can take 2 different charges. So I'm going to show you both equations. Both of them would be acceptable. Both of them would be okay for answers. So here I'm going to have iron 2 oxide plus hydrogen. And hydrogen we know is going to be standing alone. And hydrogen is another one that's going to be a diatomic. Now the other possible one that I could have here is instead of iron 2 oxide, I could have iron 3 oxide. So in that case, what I need to look at right here is that's going to be that plus hydrogen. So here in the top one, that's iron 2 oxide with a charge of +2. Down here, that's going to be iron 3 oxide with a charge of +3. And that's how those would cancel out there to make that. Here's just my original one. Top one is already balanced. I don't need to do anything else to that. The bottom one, I do need to add a couple subscripts, and now it is completely balanced when I put that 2 in front there. Both of those would be examples, though, of single displacement reactions, because you can see iron arrives by itself but leaves with a partner. And again, either one of these would be acceptable answers. I'm not going to insist that you do both of them, but they both would be single displacement reactions. Magnesium bromide plus chlorine. So we have MgBr plus Cl. And now I need to check my diatomic, have no fear of ice cold beer. We know that chlorine is going to be a diatomic, so I need to have 2 there. Bromine has a charge of -1, magnesium has a charge of +2, so that means that I need 2 bromines to account for that. Chlorine is by itself, so now I'm going to switch those around. So it's going to be magnesium chloride plus bromine. Bromine, another one of our diatomic ones, so I need to make sure I have the 2 subscript there. Working out the charges, I have 2 +2 for magnesium, -1 for chlorine, so that means I need 2 chlorines to balance it out. Now, need to look at this. This is a single displacement reaction and everything else is balanced. Silver 1 chloride plus aluminum sulfate. So I have AgCl plus AlSO4. So now I need to check my charges. Silver 1, so that's telling me it's a charge of +1. Chlorine is -1. Aluminum is going to be +3 and sulfate is -2. So in order to cancel those out, I need to use the crisscross method. So I'm going to have 2 aluminums and 3 sulfates. Now that is going to switch around, and I'm going to be getting silver sulfate, because the silver is now going to be leaving with someone new, plus aluminum chloride. So now let's check my charges. Silver is going to be +1, sulfate is -2, so that means I need to bring that down to silver to account for that. Aluminum is a charge of +3, chlorine is -1. So what I need for that one is 3 chlorines. Now I need to balance that out. That's the double displacement reaction. As I mentioned, 3 times 2 over on the right is going to give me 6 silver, so I need 6 silver on the left. That's going to mess up my chlorine, so I need to fix that with the 2 right there, and now I am balancing my double displacement reaction. Aluminum plus copper 2 chloride. So aluminum by itself plus copper chloride, and we're specifying that it's copper 2. Aluminum, by the way, not one of my diatomics, so I don't need to worry about putting any sort of subscript right there. Copper is going to have a charge of +2, chlorine is -1, so I need to use the crisscross method and bring that down. Now I'm going to be left with aluminum chloride and copper metal on its own. Copper, another one that is not diatomic, so it doesn't need a subscript. But I know that aluminum is a charge of +3, chlorine is -1, bring those down with a 3 there. Now we can balance that out. 2 aluminums on the right, need to fix it on the left in a minute, but I'm left with 6 chlorines there. Bring this to 6 over there and balance it out with those subscripts there. This is going to be a single displacement reaction.